हेलो दोस्तों, आई होप आप सभी अच्छे होंगे। चलिए विदाउट वेस्टिंग टाइम शुरू करते हैं आज की अपनी ये नई वीडियो।
Wave optics. In the previous chapter, ray optics, by assuming that light travels in a straight line, we easily explained the concepts of reflection, refraction, and dispersion. Now, the question is, does the light really travel in a straight line? Now, observe the illustration. Consider a light source illuminating a screen. If we place a coin in front of the light, the coin obstructs the path of light. If the light travels in a straight line, then we should see a dark circular spot on the screen. However, this does not happen. In fact, we get a bright spot in this place. This can only happen if the light bends at this point and reaches this spot. To explain the bending of light, in the year 1678, a Dutch physicist Christian Huygens proposed a theory called wave theory of light. When a stone is dropped into a stagnant water of a pond, waves spread out from the point of impact in concentric circles. Every concentric circle is associated with either a crest or a trough. If we consider any concentric circle, all points on the circle will oscillate with the same phase. This is because they are at same distance from the point of impact. A locus of all these points which oscillate in the same phase is called a wavefront. The speed at which the wavefront moves outwards is called speed of the wave. Now, draw a tangent at a point on the wavefront. Then, a line drawn perpendicular to the tangent at that point is called a ray. The ray is the direction along which the energy of the wave travels. Christian Huygens applied the same theory to the light and proposed that light travels in the form of waves. A point source generates spherical waves in 3 dimensions.
Best example is the plane waves which arrive from the sun. At large distances, a small portion of a spherical wavefront appears to be a plane wavefront. Now, if we know the shape of a wavefront at a time t is equal to 0, using Huygens principle, we can easily determine the shape and position of the wavefront at a later time. Let us consider a point source S. The source S generates a spherical wavefront AB traveling away from S. Now, according to Huygens principle, each point along the wavefront AB is the source of new disturbance, and spherical secondary waves originate from these points which spread out in the forward direction. These secondary waves are called as wavelets. If we assume that the medium is isotropic, then the velocity of wavelets will be same in all directions. The radius of secondary wavelets is given by r is equal to v into t. Now, if we draw a tangent to all these waves, we will get the position of the new wavefront a dash b dash. When time t is equal to 0, the radius of secondary wavelets will be equal to 0. It represents the initial position of the wave. When time t is equal to tau, the radius of the secondary wavelets will be equal to v into tau, and this will be the new position of the wave. In the similar manner, we can determine the shape of the wavefront of a plane wave going through a medium in forward direction. Unfortunately, there is one problem with this theory. Since the secondary wavelets are spherical, it will not only generate forward wavefront, it will also generate backward wavefront. But in practice, we do not find any back wave. To correct this problem, Huygens suggested that amplitude of secondary wavelets is maximum in the forward direction and 0 in the backward direction. Later, Voigt and Kirchhoff mathematically proved that the amplitude of wavelets in any direction making an angle theta with the normal to the wavelet is proportional to 1 by 2 into 1 plus cos theta. Since theta for a back wave is 180 degree, the factor 1 by 2 into 1 plus cos theta will be equal to 0. That is why there is no back wave formed. Huygens' principle is also useful in explaining the phenomenon such as reflection and refraction of light. We will study about these in the upcoming videos.
दोस्तों, आपको वीडियो कैसी लगी हमें कमेंट करके बताइए। यदि अच्छी लगी हो तो लाइक कीजिए, चैनल को सब्सक्राइब कीजिए और दोस्तों के साथ इस वीडियो को शेयर कर दीजिए। और यदि आपको आने वाले चैप्टर की ऐसे ही शॉर्ट इम्पोर्टेंट वीडियो चाहिए तो बेल आइकन दबाना ना भूलिए। थैंक यू।